Before just diving in and taking a swing at implementing this strategy pattern, let's take a look first at its intent. The intent of the strategy pattern is primarily to encapsulate a related, or we could say family, of algorithms such that they are callable through a common interface and may be used according to the appropriate situation. The idea here is that we're going to let our algorithms vary as independent classes so that they might evolve separately from the classes that actually invoke them through the interface. This allows our classes to maintain a single purpose. In the case of our shipping cost calculator, it's going to be responsible for taking an order, executing a calculation about that order, and returning the results. What we don't want is to bleed all of the concerns of UPS versus FedEx versus other shipping services into our shipping calculator. That would not allow our class to maintain a single purpose. And this nicely separates the calculation itself from the delivery of the calculation's results. Well, what are some flags we can look for that let us know the strategy pattern might be applicable to our situation? First of all, we've got switch statements. Anytime we see switch statements in a method that's trying to choose which calculation it should perform, that really should be a red flag to us. There is very likely a better object-oriented way of determining that logic than a switch statement. So switch statements are kind of a red flag. Also, we know that adding a new calculation, like one for DHL, will cause our class file to be modified. And we've already said that we want our open-close principle intact. So these are good indicators that we might want to look at an alternative. The alternative that we have implemented is an example that creates classes for each type of calculation we want to perform and uses a common interface for each one of those calculations so that they might be shared by the calculator class. Let's see how this looks in a classic UML model.